In this tutorial, we're going to look at rules when you are adding and subtracting measurements, how many significant figures to round your answer to, and then we'll end with kind of a culminating problem that will mix both of the rules, the multiplication, division, and then also the addition, subtraction. So when you're adding and subtracting, that's a little different. You're actually going to throw out the window all of the sig fig rules that we have learned about. And all you look at when you are adding or subtracting measurements, as far as significant figures is concerned, all you're looking at is how many decimal places there are. So how many numbers there are past the decimal point. It does not matter if it's a 0, a 5, a 2, none of that matters. All you're just doing is counting how many numbers you see past the decimal point, and you have to round your answer to the least number of places past the decimal point that you see from your measurements. This one's actually a lot easier than the other ones, but it confuses students the most because they really want to use the significant figure rules that we've been talking about, but you don't use them at all. It's actually a lot easier, but it just throws students off because they want to try to put them in here. So remember, adding and subtracting, don't use the sig fig rules. All you do is take a look at your measurement. So in the first one, I see that I have 1, 2, 3, 4 places past the decimal point. Again, doesn't matter what they are, what numbers they are, just how many are there. The second number has 3 places past the decimal point. So my answer, whenever I go to give it, can only have 3 places past the decimal point. If you go ahead and solve that, you'll see that you get 5.3853 is what shows up on your calculator. So whenever you're rounding it, I can only keep 3 places past the decimal point. I do keep however many numbers are before the decimal point, I keep all of them. So in this case, there's just the 5, so that just is kept. All I'm doing when I'm adding and subtracting is seeing how many numbers past the decimal point I can keep. So, and this is going to tell me 3. I go with the lesser of the 2. So 1, 2, 3 numbers after the decimal point, the 3 drops off. Since it's not a 5 or higher, it will not affect this number. So I will just carry down those 3 places past the decimal point, and that is my final answer. In the second example, again, these are just from the textbook. This is under the measurement, uncertainty, accuracy, and precision section. Just continuing down with that went through all the sig figs. This one, we have 2 numbers we are subtracting. So if I look at this first number, I see that there are no places past the decimal point. There's not even a decimal point in the number. So this would be 0. And then my second number has 2 places past the decimal point. So if I subtract those 2 numbers on my calculator, I'm going to get 64.77. What's before the decimal point, I automatically keep all of that. So those 2 numbers will stick. Let me wait a second. If I look at these 2, this one has 0 numbers past the decimal point, so my answer can only have 0 numbers past the decimal point. So that means all of these are going to go away and get dropped off. Before it gets dropped off though, this 7 will round that up. So my final answer is going to be 65. Okay. All right, so now we're going to show an example mixing them together like for a density problem. And this is example 5 in the same section that we've been in. It talks about lowering, in this case, a rebar into a graduated cylinder and seeing how the water level changes and calculating the density based on that. So in order to find density, we know that it's mass divided by volume. The mass is given to me right here, but the volume I have to do a little calculation to find out. I'm told the volume in the graduated cylinder before I drop in the rebar and after I drop off the rebar. So the difference between those 2 numbers is the actual volume due to the rebar. Now, this first step in finding my volume requires me to subtract two numbers. So whenever I go to get this answer, I have to round this answer using the subtraction rules. So that means that we know, looking at this number, I just look at how many places are past the decimal point. This has one place past the decimal point. This has one place past the decimal point, so my answer can only have one place past the decimal point. What's kind of nice is when you plug this in your calculator, the answer actually ends up having one place past, so there's nothing additional that you have to do. So always follow the significant figure rounding rules for whatever math function you are doing. So since the first part of this density problem we had to subtract, I want to follow the subtraction rules to round that answer, and then that rounded answer gets plugged into the next part of the problem, solving density. So I'm going to go ahead and take the mass that I'm given in the problem, and I'm dividing it by the volume that was rounded using my subtraction significant figure rules. When I do that, I get a monstrously long number, which is why we really actually need to be thankful for these rules. All right, when I'm dividing, that's going back to counting the total sig figs. So this first problem has 5, measurement has 5, the second one has 2. When you divide, you go by the least total number of sig figs. So that means my answer can only have 2 sig figs. So all of that gets dropped off. The 2 doesn't do anything to the 8, so 7.8 grams per milliliter is my final answer.